Welcome to the Deep Dive. We're here to cut through the noise, get straight to the core insights from really important sources and ideas.
Yep.
Today, we're taking a plunge into the thinking of Andrew Ng. He's, a huge figure in AI.
Absolutely. A real leader.
We're looking specifically at his talk, Building Faster with AI, from Y Combinator's startup school.
And Andrew Ng, he's not just like an academic observer. He leads AI Fund. It's a venture studio, and they're co-founding about one startup a month.
Wow, a month?
Yeah, so he is deep in the weeds actually building things. And his main lesson for founders, it's pretty clear.
Okay.
Execution speed. It's a really strong predictor of success.
Yeah.
And he argues this new AI tech lets startups go just much, much faster. We're going to unpack how.
Okay, so our mission today is really to distill those best practices for you. And these are practices, honestly, that seem to be changing every, 2 or 3 months.
Easily. It's moving that fast.
The whole point is to give you that speed advantage, boost your odds of success in this, incredibly fast-moving AI world. So, okay, let's start maybe at the bottom. The AI stack itself. A lot of people, when they think opportunities, they think, the foundational tech.
Yeah, the deep tech, semiconductors, cloud providers, the big model companies.
But N has a different take, right?
He does. He lays out the stack, from the ground up, semiconductors, then cloud hyperscalers, then the AI foundation model companies, and then at the top, the application layer.
Okay.
And yeah, you're right. Most of the hype, the PR, it focuses down low. But N's point, and it's fascinating, is that almost by definition, the biggest opportunities have to be at the application layer.
Have to be. Why? Why the application layer?
Well, because that's where the money comes from, right? Applications generate the revenue. That's what pays for all the underlying tech.
Ah, okay. The value capture.
Exactly. So if you're thinking, where should I build? And you really ought to be looking at that application layer. That's where the real economic value gets created.
That makes a lot of sense. Okay, shifting gears a bit. N talks about the rise of agentic AI. He calls it the most important tech trend in the last year.
Yeah, it's a big one.
Now, marketers have kind of jumped on that term, maybe muddied it a little. What does he mean, technically?
Good question. So think about like a standard large language model. Often it generates output linearly.
Linearly?
Yeah, like imagine asking it to write an essay just by typing from the first word to the very last word, straight through, no backspace.
Okay, just one pass.
Right. Agentic workflows are different. They let the AI system work iteratively.
Yeah.
Think more like how a person works.
Okay, how so?
So for that essay, maybe it would first write an essay outline, then do some web research, then write a first draft, then read the first draft and critique it and revise it.
A loop. Plan, execute, review, revise.
Exactly. It's an iterative loop. Now, it takes longer, more steps involved.
Sure.
But Ng says it delivers a much better work product, consistently better.
So it's like AI thinking, reflecting, improving its own work.
Pretty much. And for really complex stuff like pulling specific compliance documents or medical diagnosis, even legal reasoning, he says this iterative approach is absolutely critical.
Critical how?
Yeah.
Like make or break.
Yeah. He says for many projects at AI Fund, it's been the huge difference between it working versus not working. It's that significant.
Wow.
And this whole trend has actually led to a new kind of layer emerging, an agentic orchestration layer, which basically makes building these iterative applications even easier.
Okay, so AI systems are getting more reflective, iterative, and there are new tools to manage that. How does that change how you actually build a startup? Ng says it starts way before coding, right? With the idea itself.
Yes, absolutely. He's really, really strong on this point. Focus only on concrete ideas.
Concrete ideas.
Yeah. And a concrete idea, for him, is one specified in enough detail that an engineer can go and build it.
That feels kind of limiting, doesn't it? We're always told, think big.
It seems like it, but his point is about actionability. He contrasts it, right? Use AI to optimize healthcare assets. Sounds impressive, but it's vague. What does an engineer do with that?
Right, yeah. Nothing specific.
Compare that to, let hospitals let patients book MR machine slots online to optimize usage. That's concrete. An engineer knows exactly where to start.
Okay, I see the difference. One is a wish, the other is a spec.
Exactly. And the tricky thing, he points out, is that vague ideas tend to get a lot of kudos. They sound good, hard to disagree with. You're almost always right when you're vague.
Huh.
But being concrete, that lets you find out quickly if you're right or wrong. And finding out quickly is key for speed. It forces you to test reality.
So concreteness equals faster learning.
Yes, and finding those good concrete ideas often takes a subject matter expert, someone who's been, wrestling with a problem for a long time.
The idea maze thing YC talks
But
about.
that's what he calls it sometimes. Wandering the idea maze, deeply exploring the problem space.
Okay, so you need that deep expertise.
Yeah.
But then he says something surprising about gut feeling over data.
He does. This is where it gets really interesting. He argues that after someone has done that deep thinking, that wandering the maze, their gut, their instantaneous decision, can actually be a surprisingly good mechanism for making speedy decisions.
Better than data
Uh-huh.
for an early startup.
Often, yes, because gathering rigorous data can be slow, especially early on. An expert's intuition honed by deep thought can be a faster and often quite accurate guide.
So the takeaway for you listening is what? Trust your gut, but only if you've done the homework.
Kind of. Eng suggests successful startups often pursue one very clear hypothesis, really doggedly, go all in on that concrete idea.
Okay.
Now, if data comes back and clearly says you're wrong, fine, pivot. It's totally fine to pivot on a dime to pursue a totally different concrete idea.
Right. Don't be stubborn.
But he adds a caution. If every little piece of data makes you pivot, constantly changing direction, it might mean your initial knowledge base was just too weak. You didn't wander the maze enough. It's about informed conviction, not just random guesses.
Informed conviction, fast pivots when necessary. Got it.
Oh.
And this iterative, fast approach extends to engineering too, right? The whole build feedback loop is changing.
Completely. And one of the biggest startup risks, and always highlights, is building something cool that nobody cares about. Customer acceptance risks.
The classic problem. So how does AI help there?
Well, AI coding assistants make rapid engineering just way more possible. Engineering speed goes up, costs go down dramatically.
Right. But is that for production code or just messing around?
Good distinction. He says for production quality code, AI might make you, say, 30–50% faster, which is great.
Still significant.
But for quick and dirty prototypes, he finds those are easily 10 times faster, maybe much more than 10 times faster.
10 times. How?
Because prototypes don't need perfect integration or rock-solid reliability or scalability or even tight security initially. He actually tells his teams, for early testing, go ahead, write insecure code. Just make absolutely sure you secure it before it ever ships to a customer.
Wow. That's liberating in a way.
It is. It means you can now systematically pursue innovations by building 20 prototypes to see what works. Try lots of things. It's actually fine if lots of proof of concepts don't see the light of day.
So the cost of experimentation plummets.
Exactly. His new mantra, kind of updating the old Facebook one, is move fast and be responsible.
Move fast and be responsible. I like that.
And what's really wild is how this changes the value of code itself. Since building software is getting so much cheaper and faster,
Yeah.
the code itself becomes much less of a valuable artifact. It's less precious. He mentioned teams at AI Fund literally completely rebuilt a code base 3 times last month.
3 times in a month. That's incredible.
It is. And think about what that does to big strategic decisions.
Like, right.
Like Jeff Bezos' old idea of one-way versus two-way doors, decisions that are hard or impossible to reverse versus decisions you can easily back out of.
Right. Choosing your tech stack used to feel like a huge one-way door.
Totally. Very costly to change course. But now, Eng sees teams more often just throw the code base away and redo it from scratch on a new tech stack, if needed.
So more decisions are becoming two-way doors.
Exactly. Or at least the cost of going back through the door is much lower. It fundamentally changes how you approach building things.
Okay, if code is becoming less precious, easier to generate,
Mm.
does that mean fewer people need to code? Or maybe, should everyone learn? Eng has a view on this, doesn't he?
He does, and it's pretty controversial for some.
Oh.
He thinks telling people don't learn to code, AI will automate it, will be seen as some of the worst career advice ever given.
Really? Why?
History. Think about it. When coding got easier, going from punch cards to keyboards or assembly to languages like COBOL, did fewer people code?
No, way more people started coding.
Exactly. Easier tools led to broader adoption. He sees the same happening now.
So he thinks more people should code.
He says it's time for everyone of every job role to learn to code. Everyone.
Everyone. Like the CFO, recruiters.
Yep. At AI Fund, his CFO codes, head of talent codes, recruiters code, even the front desk person codes. And he says they all perform their jobs better because of it.
How does coding help a recruiter, for example?
Because the most important skill, he argues, isn't necessarily writing complex algorithms, but the ability to tell a computer exactly what you want, to articulate your needs precisely.
Ah, so coding is the best way to learn that precision, that structured thinking.
He thinks so. Learning to code, or even just learning how to effectively steer AI to code for you, is the best training for that crucial skill.
Interesting.
He gave this great example. An art history expert could use Midjourney to generate incredibly specific, nuanced art because they knew exactly what prompts to use, drawing on deep domain knowledge.
Whereas he, without that expertise,
He could only ask for pretty pictures of robots. He lacked the specific language, the structured request capability in that domain.
So for your career, learning to code isn't just about tech jobs. It's about learning how to communicate effectively with AI, leveraging your own expertise.
That's the core idea. It's about becoming AI literate in your own field.
Okay, so engineering is getting faster. Everyone's learning to guide AI. Where's the new bottleneck?
Ah, yes. With engineering speeding up so much, the bottleneck shifts. It's often now in product management work.
Product management, like deciding what to build.
Exactly, getting user feedback, synthesizing it, prioritizing features. That whole cycle is now often the slow part.
So the ratios are changing. Fewer engineers needed per PM.
Potentially, yeah. In mentioned one team actually proposed a ratio of 1 PM to zero point 0.5 engineers,
Half an engineer per PM. Wow.
meaning twice as many PMs as engineers. Now, that's maybe extreme, but it shows the shift. He finds that PMs who can code a bit, or engineers with good product sense, tend to thrive because they bridge that gap.
Makes sense. So how do you speed up that product feedback loop then, if that's the new bottleneck?
Right. Eng shared what he calls a portfolio of tactics for getting feedback, ranging from fastest but maybe less accurate to slower but more accurate.
Okay, what's in the portfolio?
Number one, fastest. Your own gut. If you are a genuine subject matter expert who's wandered that idea maze.
Okay, the expert intuition again.
Second, ask 3 friends or teammates. Quick gut check. Third, ask 3 to 10 strangers.
Strangers. How?
This is Eng's personal go-to. He literally goes and sits in the coffee shop or a hotel lobby and respectfully grabs strangers for quick feedback on a prototype or idea.
Seriously, people are okay with that.
He finds they usually are. People are often happy for a quick distraction, surprisingly willing to give a few minutes of feedback.
Huh. Okay, what's next?
Then you scale up, send prototypes to maybe 100 testers, then maybe prototype to even more users.
Getting slower, more data.
Right. And then, way down the list, surprisingly, is A/B testing.
A/B testing is slow now.
Relatively speaking, yes. In this super fast iteration world, setting up and running rigorous A/B tests is actually one of the slowest tactics.
That's a big shift in thinking.
It is, and the key insight isn't just getting the feedback faster, it's what you do with it.
Meaning?
Don't just look at the data, whether it's from strangers or A/B tests, and pick option A or option B. Use that data to hone our instincts, to update our mental model.
Ah, so the feedback loop improves your gut over time.
Precisely. It's about continuously improving the quality of your fast decisions, making your gut smarter, faster.
That's powerful. Okay, another point Eng makes is that just understanding AI better makes you faster. How does that work?
Yeah, it sounds simple, but it's crucial. Unlike, say, mobile development, which is pretty mature.
Right, the best practices are well known.
Exactly. Knowledge of AI is still not widespread. So teams that really get it, understand the nuances, the capabilities, the limitations, they just have a massive advantage.
It's like having a better map.
Sort of. It's about making the right technical decisions quickly. Knowing, for example, what kind of accuracy is realistic for a chatbot task, or how to architect for low latency voice output.
And the wrong decision costs you.
Weeks, months maybe. Making the right technical decision might solve a problem in days. The wrong technical decision could send you down a blind alley for 3 months. You end up taking 10 times longer than a team that understood the tech better.
Wow, okay. Knowledge is literally speed.
It really is. He uses this great metaphor. Gen AI tools and all the techniques prompting, agentic workflows, evaluations, guardrails, R for external data, embeddings, fine-tuning.
Yeah, all those building blocks.
He calls them Lego bricks. The more different kinds of Lego bricks you understand and have in your toolkit.
The more complex and interesting things you can build.
Exactly. The combinations become combinatorially or exponentially richer. He even mentioned he takes courses on deep learning AI himself just to learn about new bricks.
So continuous learning is non-negotiable.
Absolutely. And a practical tip he gives: build your system so that Switching between different building block providers, relatively easy.
Like swapping out one LLM for another.
Yeah, maybe one week, one model is best based on your evils, the next week, another one is better. Having that flexibility lets you keep moving fast even as you build more complex things. You aren't locked into a potentially suboptimal choice.
That makes sense. Okay, with all this speed, this rapid change, there's also a kind of hype, right? How do we separate real potential from, just noise?
Yeah, it's tough. Aang offers a helpful mental filter.
A filter.
He suggests asking, is this narrative being amplified because it makes certain businesses look more powerful for PR or maybe fundraising?
Follow the incentives.
Yeah.
What kind of narratives does he think fall into that hype category?
He's pretty direct. Things like AI will lead to human extinction, or soon no one will even have a job anymore, or that AI is wiping out thousands of startups.
He thinks those are overblown.
He calls them ridiculous or just not true. Same for the idea that AI needs so much electricity, only nuclear power is good enough. He pushes back hard on that kind of sensationalism.
Okay, but what about the genuine risks? AI safety, potential downsides? He talks about that too, right?
He does, but he frames it differently. He prefers the term responsible AI over AI safety.
Why the distinction?
His argument is that safety is not a function of technology, it's a function of how we apply it.
Okay.
He uses the analogy of an electric motor. The motor manufacturer can't guarantee safety, right? It depends if you put it in an electric drill or something dangerous, like a smart bomb.
It's the application that matters.
Exactly. How you apply it that makes it safe or unsafe. He cautions against overreacting to weird corner cases that researchers might find in a lab setting but aren't realistic applications.
So for you, the builder, what's the ethical guideline then?
It's pretty straightforward, actually. He says, look in your heart, and if fundamentally what you're building, if you don't think it'll make people at large better off, don't do it.
A personal ethical check.
Yes. And he practices it. He said AI Fund has actually killed multiple projects, not because they weren't financially viable, but purely on ethical ground.
That's significant.
He also really emphasizes bringing everyone with us, empowering non-engineers to use these tools so the benefits are shared broadly.
Makes sense.
And related to hype, he sees a real danger when companies hype up dangers specifically to push for regulations.
Why is that dangerous?
Because often, he argues, those proposed regulations end up creating gatekeepers. They put heavy burdens, especially on access to large foundation models, that make it super difficult for smaller players, particularly open source projects, to compete or even exist.
So regulation could stifle innovation, especially from the bottom up.
That's his concern. He mentioned a specific bill in California, SB 2047, which thankfully didn't pass. He saw it as imposing huge, costly requirements that wouldn't actually improve safety, but would definitely hurt open source.
Interesting perspective. So in this world where tech changes fast, code is less precious, maybe even traditional business modes are less secure,
Yeah.
what's the most important thing?
Eng brings it back to basics. Build a product that users love. That's still the core challenge and opportunity.
And he sees plenty of opportunity.
Tons. He concludes that the number of real opportunities at that application layer seems much greater than the number of people with the skill to build them. It's basically an open invitation.
Wow. Okay, we have covered a lot of ground today. Building faster with AI, starting with concrete ideas, embracing expert gut.
Yeah, then turbocharging engineering with prototypes, rethinking code value, the whole two-way door shift.
Plus getting faster product feedback, honing your instincts, and just how crucial understanding AI is for speed.
And Andrew Ng's core message really weaves through it all, right? Speed is vital, but it has to go hand in hand with responsibility, with constant learning, and really focusing on empowering everyone.
Absolutely. So for you listening, here's the big thought to maybe wrestle with. In this world where building and iterating software is getting radically cheaper and faster, where expert gut is a valid, speedy tool, how does that change what a one-way door decision looks like in your work, in your field?
Yeah, what assumptions about irreversible decisions need rethinking?
What does this new speed and flexibility unlock for you? We really hope this deep dive gave you a bit of a shortcut to getting informed and maybe, just maybe, spark some new ideas for your own journey ahead.